It's been about a month since the last update. So past week I was at GDC, which is the Game Developers Conference in San Francisco. It was interesting to meet some people. I didn't really get a lot out of the convention itself, but I did get to meet up with some people that I've known through Twitter and so forth for a long time. So it was good to talk about some things with them. But aside from that, past month I had been working mostly on the AI. As I've mentioned in the forums, there wasn't very much interesting to show. I've shown a couple of things sometimes in the Twitch stream, but now I actually have the AI working, at least in the console. You know, I can input in queries and things and compile these AI scripts and make deductions and so forth. I'll show that in a second. First, a little thing I added in just to make better visual deductions about the world. I kind of fixed all the icon ordering and everything, and added in some NPC and monster icons from a placeholder set. That same guy, there's 7 Soul on DeviantArt. So overall about $30 for, you know, a couple hundred items and monsters and NPCs and stuff, so pretty good deal. You can buy his stuff on, you know, most of those game dev markets and asset markets and things like that. So anyway, I've added in these visual, basically billboarded representations of the objects and monsters and things like that. All these objects are containers, so they actually link up with the icons. There's a couple bugs I still have to fix here, like selecting on the icon versus the bounding box that surrounds it is still kind of functioning weird, so I need to fix that. But basically just supports these little billboarded sprites to make visualizing everything easier, so I'm not just looking at placeholder boxes. So it's good. It's good enough to, you know, make sense of things for right now. On the AI side of things, I've added in. Let's drop a couple objects here just so you can see something besides the containers. Okay, so let's look at more monsters. There's a mimic. Somebody requested a mimic, so we've got that in there. Yeah, so anyhow, on the with regards to the AI, let me go over that really quickly. Okay, so let me describe the language that I'm using here, that I've created. Basically, it's just to get a parser running quickly. I just based it off of parsing JSON, so you're really parsing strings and arrays of strings and arrays of strings of numbers and things like that. So actually the way that you spell variable names in terminals and things makes a difference in terms of the function of it. So N, the names that start with an N are a noun or a terminal. Basically, they're not a variable, they've been deduced to something. You can think of it just like a noun in the English language. A V is a variable, it can bind with other things like any of the other things that I've listed here. The P is a predicate. It's sort of like function that describes relations between other predicates or nouns or variables or things like that. I'll describe how all that works in a second. Then things that start with O or operators, they're special symbols that are used for determining how certain things in the language work. So basically, you build up this vocabulary of words. It's kind of the same as defining a variable in another language. Here I have to define some operators, some variables, some nouns, some predicates, and so forth. So let's look at some of the things I've listed. So basically the way the AI works is you create this knowledge base where there are you're describing different relations between predicates and nouns and things like that. So here's a pretty simple example. It says, and I'll show you how to read this. So this is basically saying if some variable x is a precious metal, then the variable x is also a metal. And then there's more complicated things like if any of these are true, then this is true. So it's saying if it's copper, silver, gold, or platinum, it's a precious metal. If it's bronze, iron, or steel, it's a metal. If it's oak, redwood, or yew, it's a wood. If it's sandstone, marble, or granite, it's a stone. If it's, I'm not sure how to pronounce it actually. Is it onyx or onyx? Amethyst, topaz, sapphire, emerald, ruby, or diamond, then it's a gemstone. If it's cotton, linen, or silk, it's a cloth. And so on and so forth. So we get into some more interesting deductions here. If it's worn, then it's equipable. So if an item can be worn, then it is equipable. If an item can be held, then it is equipable. If the item is a tool, then it is considered to be held. If it's a weapon, it is also held. If it's a sword, it's a weapon. If it's a sword, it requires one hand, I'm stating here with this predicate. If it's a bag, it's a container. We have to find some artifacts. If it's a sword, if it's an iron sword, then it is both a sword and it is iron. So I'm just going over some of these, listing some of these predicates to give you an idea of how things work when they're defined. Here I'm saying if it's cloth bag, it's cloth and it's a bag, and here the the properties aren't necessarily a sum of the words that denote the predicate or variable or whatever. So this could just as well be anything else. It could be P is XYZ, and you could say it's cloth and it's a bag. So the deductions are not always that obvious. Here I'm saying n item 0, so item 0 is a noun or a terminal. I'm saying it's an iron sword, and item 1 is also an iron sword. And then I have a more complex definition here, which is basically defining jealousy. So it's saying if all of these are true, if some variable x loves some variable z, and some variable z loves some variable y, then we say that x is jealous of y, and they share the love interest z. So I've also defined a couple things here. Steve loves Sue, Bob loves Sue, and Sue loves Steve. And then I have a query here. So we're posing a query to the system, and it's basically giving it these variables, and we're saying fill in the blanks pretty much. So I'm asking what variable x, what variable y, and what variable z passed into the predicate is jealous, can be solved such that this statement is true. So let's see what happens when I run this. So I'm going to run this now. Let's clear the console output. Okay. So I just compiled the script, And you can see when it compiles a script, it does a whole bunch of stuff. It looks over the vocabulary to make sure all the words are valid. It generates these special namespaces for variables. You can see VX0, VX1, VX2, VX3. So each rule that's specified in the knowledge base has its own namespace, just like you would uniquely scope a variable to a function in another language. And then we have basically the resulting compiled sort of bytecode. There's a symbol table, so you can look up the bytecode, which is how it's printing it out. So to be relatively fast, rather than looking at strings, it looks at integers, and all these integers represent some symbol in the knowledge base or vocabulary or whatever. Just as you would use a symbol table in another compiled language for debugging or whatever. So here we have the language. It's, goes over all the rules. It's showing me, what variables are namespaced to, how they're namespaced uniquely within each rule and so forth. Okay, so it's compiled the knowledge base, and then it's kind of going over, okay, what's it doing, what are the steps it's taking. So it's operating as a logic language like Prolog would. In fact, this is exactly inspired by Prolog, although it's a subset and it has some extensions, which I'll describe in a second. So we have something here where we are basically trying to unify my statements with any existing statements in the knowledge base, or unify my query. So here we're searching, we're trying to bind the predicate P is jealous with those arguments we passed in X, Y, and Z. So it attempts to unify it, and it sort of drills down into the unification and finds rules that it can unify, and if that rule is another predicate, it attempts to unify that, and so forth recursively. If it fails, it rolls back variable assignments. Variables can only be assigned once, so if it tries to assign a variable that's already been assigned, it will fail, and it will roll back the assignment and try to bind the next rule. And if you're interested in how all this works, I recommend examining a language like Prolog. I've provided a link to it, if I remember to, in the next update that I'm writing. There's a free book on it online that you can read. And you can also look into things like lambda calculus and things like that if you're not familiar with how this works. So basically it goes through, tries to unify these things. Sometimes it fails, it rolls back stuff until it arrives at a solution. And when it arrives at a solution, it basically shows me which variables were bound to which other variables and other rules, and eventually to terminals, in order to solve this query that I've passed in. So in this case, it's saying VX24, VY24, VZ24. These are all variables from that very last rule, which is basically the query that I passed in. It's binding these to some other rule, which in turn bound them to these terminals, which were found in other rules. So it's saying V of X is equal to Bob, V of Y is equal to Steve, and V of Z is equal to Sue. So let's see if that is actually correct. So if we look at our knowledge base, we specified that Steve loves Sue, Bob loves Sue, and Sue loves Steve. So it was able to solve this by saying that Bob is jealous of Steve. So is that correct? So Bob loves Sue, and Sue loves Steve. Therefore, by the rule, the way that we specified the predicate is jealous, it has in fact solved this and made a deduction that Bob is jealous of Steve because Bob loves Sue and Sue loves Steve. So That's just one example of how it can solve something like this. We can also pose more generic questions, like we're saying P is equipable V of X. Okay, solve this. Which, from all the rules I've specified in terminals and everything, what items are equipable? So if I clear my output here and run this again, so it basically recompiles. Oh, I made something invalid. Let's see what it is. I am not sure what I did that was invalid here. P is equipable. P of X. Aha. I forgot a comma. Whoops. Okay. So now that I've included this comma, and it's a good thing it catches, that if the JSON I created was invalid, that would bring the whole thing tumbling down. So let's try and recompile this. So let's compile it again. Okay, this time the compile succeeded. So I was posing a query into the system, which item V of X is equipable, and it finds the first such item that isn't necessarily in the order the way the rules were specified. So it says, okay, what's equipable? Well, let's bind that to some rules. Let's bind it to the rule. It says if something is held, it's equipable. And then let's say, okay, it's a weapon. Weapon is held. A sword is a weapon. And it kind of attempts to do this on some different things. I have one sword that defined that doesn't result, which is just some artifact that I specified. It doesn't result in a terminal, so that fails and it rolls it back. And eventually it lands on, okay, so we have an iron sword as a sword, and it turns out n item 1 is an iron sword. So we've got this sort of chain of deductions that leads us to, okay, I've asked for an item that's equipable, and it says n item 1 is equipable. And in this case, n item 1 is an iron sword is a sword is held, and items that are held are equipable, so it's able to make deductions like that, recursively chaining it down. That's a pretty simple example of one thing it can do. We can also change this such that here's another interesting thing we can do. So we can we actually don't need to pass 3 arguments into P is jealous. We can ask, okay, who is jealous of who, and let's not worry about who they love. Let's just solve it for Vx and Vy and run that. So let's clear this, recompile it. Okay, so it says, oh, now it has failed because I forgot to specify within the definition that we're actually binding it to just 2 variables. So it can only unify functions that have the same number of arguments or predicates. So let's fix that, and then let's retry this. Let's clear the output, recompile that. Okay, so now it's determined that Bob is jealous of Steve, and we don't care about that 3rd variable. It turns out that Bob loves Sue, and Sue loves Steve, but we're only asking who is jealous of who, so it solved that for us, completely ignoring the 3rd variable. And that's just one neat little trick you can do in terms of deductions, where you're only interested in certain things, certain relevant variables, even if it involves additional variables. So you're probably wondering, if you're not too technically oriented, what the significance of all of this is. So this is just one sort of piece to the AI puzzle. so to speak. I'm also including a sort of extension on this, which is involves planning and score maximization, which is you know, like you would find in an A-star algorithm or any sort of score maximization algorithm. And I'm kind of tying that into this to basically allow the AI to both make deductions and see which state changes result in you know, new deductions or states that basically put the AI closer to whatever goals it has. And that's pretty straightforward score maximization. I give it a set of goals, and you know, I weight those goals, and I say, okay, do the action that makes the most sense. And really, this hasn't been done in games for the most part. There was one game I know of, I don't remember the name of it, that kind of, you know, it was one little sort of more of an experiment than a game, in which they tried using Prolog within the game. And there might be other examples, but it really hasn't been used in any game that's been shipped yet. So logic programming is not something you find in games, and what most people do use is something like behavior trees, where they're explicitly specifying, you know, okay, given this set of variables and their values, do this action. And that works pretty well, and it's really fast for you know, a small number of variables or states. What it's not good for is when you have many different things, and those things sometimes affect each other in ways that are not necessarily linear relations. So what this is going to allow is basically the AI to make deductions and plan around those deductions in interesting ways to create a sort of dynamic story where every NPC or monster or whatever is trying to solve whatever goals they have, and they'll do that in the best way they can find possible. You know, like for example, if some guy here was if you could say, you know, okay, this guy right here, he killed this guy's father, so this guy wants revenge on this guy, and then it might look into the knowledge base. Okay, what does getting revenge involve? Well, getting revenge, you know, maybe involves hurting the person in a physical or in a physical or non-physical manner, you know, like hurting them emotionally or something. So, you know, maybe he's a pacifist and he doesn't want to kill the guy, but he wants to get back at him somehow. And so it basically looks through the knowledge base. Okay, you know, what can I do? What weaknesses does this guy have? What can I exploit? And, you know, maybe he loves somebody and I want to make him jealous, so I get that person to love me. And that's just a dumb example, but those kind of complex deductions, I think, are what will ultimately drive you know, a story like this. And a couple of people have pointed out to me, this has been sort of a recurring thing, you know, oh, if you try to make AI too complex, it'll seem random or whatever. And I agree with that. If the AI is poorly written, it will seem random because the actions or consequences don't seem logical at all. I think that if you have a truly solid logic and you go through and you specify all your rules properly, that will make more sensible actions. I mean, the thing I always go back to is real life. You know, real life, we all behave intelligently, and it doesn't seem random at all. Because everything plays out logically. I think if you simulate even a subset of that logic within a game, you should be able to build something that seems logical, doesn't seem nonsensical, and in addition to that, as if that weren't enough, I am also initially having all the characters operate from a sort of omniscient knowledge base. So all characters know the same thing, and you can look at a given character and you can see what they know, and you can see what their motives are, and you can see what actions they took and why they took those actions. So if something seems random, you can actually inspect their motive and see why they did, you know, some certain action. So that if there was any element of it feeling random, I think that should help clarify things a bit, in addition to allowing me to easily debug, you know, oh, why is this character doing something that seems totally random. So given all of that, the portion of the AI which handles deductions is pretty much complete. There's more functions that can be added in, and probably more that will be added in terms of dynamically adding new items and removing items from the knowledge base and the queries and so forth. So it's a little bit of work to do there, and then I have more work to do on score maximization. I think once I combine both those things together, I'll be able to demo some of those deductions in the engine itself rather than the console. And there's a couple other special, you know, functions or operators we have to consider, like proximity of objects. Maybe I want it to solve a deduction for the nearest object or something like that. So yeah, that's basically it for this week that I can think of. And I will be doing probably updates a little bit more regularly now, because I'm sort of past that hurdle with the AI where there wasn't much to show beyond console input and output. So I will see you guys next week.